Hello everyone. Today we are going to learn about a new topic called MOSFET, which is one of the main backbone for the electronic product design. And myself, I am Dr. Sarin Maitri, who will be taking you for the few minutes regarding MOSFET, the basic concepts, which is a main backbone of electronic products. So now let us enter into this particular topic called MOSFET. The contents which we are going to study in this particular lecture regarding the MOSFET is first one, transistor and types, MOSFET circuit, MOSFET symbol, working principle, N and P channel of MOSFET, MOS transistor symbol, applications of MOSFET, NMOS and PMOS turn on characteristics. Then comes the advancements and limitations of the MOSFET, and last will be the regarding what is meant by MOSFET and its details. The first one, transistor and types. First of all, what is meant by a transistor? Transistor is a semiconductor device. It means that it is a device which has been formed between the two types, like conducting device and also a non-conducting device. So semiconductor is a material which has been used or which comes in between non-conducting material and also conducting metal. So now here this transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It means that it composed of semiconductor material which at least 3 terminals for connection to an external circuit. So now here in manufacturing of a transistor, there are different kinds of semiconductor, but mostly nowadays they are using a semiconductor called like silicon, which has been used in order to manufacture a transistor. So now this particular MOSFET, this particular transistor will be having at least 3 terminals will be used for making a connection with the external circuit. So now let us see the types of MOSFET. The first types of transistor. The first type of transistor is BJT, which is called as a bipolar junction transistor, and the second kind of transistor is FET, which is called as a field effect transistor. You can go to my channel and you can refer to one lecture where I have given a brief lecture regarding the invention of the transistors and different types of transistors, and the scientist who has worked really hard in order to bring up these different types of transistors like BJT and FET. You can refer to that particular lecture in my channel, which is called as Sarin Maitri's your educational mentor channel. So next one, BJT. One kind of BJT is called BJT is nothing else but it's a bipolar junction transistor, and another one FET. When it comes to the FET is of two types of transistors. First one is called as JFET junction, that is a field effect transistor, and the second one is called as a MOSFET. Here MOSFET means it's a metal oxide semiconductor field effect transistor. So these are the two types of FET transistors, and you can see in the picture there are different types of transistors which have been given in this particular picture. Next one, MOSFET circuit. So as I told now, MOSFET means it's a metal oxide semiconductor field effect transistor, which can be written as MOSFET in different ways. We have represented over here. What is this MOSFET? It is a transistor which is used for amplifying or switching the electronic signals. So this is the symbol of a MOSFET or the circuit diagram of a MOSFET. You can see one. You can see here. This is a transistor, MOSFET transistor, resistor. And again one kind of diode is connected. Again diode input is connected to the resistor and output of the diode is connected to one terminal of a MOSFET here. And you can see here between the two resistors there is a switch which mainly acts as a power signal to this particular circuit. And again the main supply voltage is given over here. So this is how a simple MOSFET looks like. Then MOSFET symbol. So this is MOSFET symbol, where you can see, as I told that in the first or second slide, MOSFET is like at least it should be having a transistor should be having at least 3 terminals. So now here when it comes to the MOSFET is not a 3-terminal device. MOSFET is a 4-terminal device. Most of you are supposed to keep in your mind that MOSFET is not a 3-terminal device, it's a 4-terminal device. What are the four terminals of a MOSFET? The first terminal of MOSFET is a source, gate, drain and substrate. The substrate, it is also called as a body terminal, or else the other name for the substrate is bulk terminal. So now here, what does the source? Source is a terminal which has been where the power has been supplied, and the gate terminal is a terminal where it's like you're supplying or triggering the input signal to this transistor, and here drain is a terminal where output has been obtained. So now the bulk terminal, bulk terminal, it is also called as a substrate terminal, or it is also called as a body terminal. Bulk or substrate is the main base of this MOSFET on which all these terminals have been formed. So you can see here in this one. See here now, this is a bulk terminal. This thing is a back contact which is given over here. So now this is a bulk terminal. Upon the bulk terminal, you can see there are two terminals like source and drain have been formed. See the formation of this, how this MOSFET is been fabricated or manufactured. There is one lecture which I have made regarding the MOSFETs. You can go back to that one. You can see that NMOS fabrication lecture, where you can clearly, it tells how each and every step by step fabrication steps I have given there, like nearly 12 to 13 steps will be there, where each how substrate has been laid upon, then again how the oxide layer has been laid, or different types of steps are there. You can go to that lecture like NMOS fabrication lecture, and you can see how this particular MOSFET is fabricated over there. So now this is like N channel MOSFET. It's a NMOS MOSFET. That's why these two terminals are of N type. It's N type of impurities have been diffused into the substrate, and then these two terminals have been formed, source and drain, and then the other terminal is called as a gate terminal. You can see these are the connection wires which runs from the MOSFET to the external circuit. And what is that? VGS. VGS is the voltage supplied between these two terminals, that is a source and gate. And what is VDS? VDS is a voltage which is between the drain and source terminal. And VBS. VBS is the voltage between the B, means, as I told, it's a substrate. The other name for the substrate is bulk. So that's why it's VBS, means it's a voltage between the bulk and the source terminal. So these are different kinds of voltages which are formed over here. And you can see here now, gate oxide. As I told that MOSFETs nowadays, it has been manufactured with a kind of a semiconductor called a silicon. So now here beneath this gate there is a kind of oxide has been formed. After forming the oxide, upon that oxide only the gate terminal will be formed. So that oxide is called as in silicon dioxide, and this is the area where gate oxide inversion layer takes place, and this is a gate oxide layer, and this is the area where inversion layer takes place. So this is a depletion region in which this drain terminal has been formed. So this is this part is a P substrate, and this is how a MOSFET looks like. So this is regarding the MOSFET symbol. MOSFET. Now let us enter into a MOSFET, into the depth, or what does a MOSFET means. That concept, let us enter into this one. A MOSFET. MOSFET is here, it's a metal oxide semiconductor field effect transistor, is a semiconductor device. A MOSFET is most commonly used in the field of power electronics, and a semiconductor is made of manufactured material that acts as neither insulator nor a conductor. As we all know that what is semiconductor? Semiconductor is a material which lies in between the two kinds of material, that is, one is an insulator and conductor, which I have told in the first slide itself. Then the types of MOSFET. There are two types of MOSFET. Basically, first one is called as an N MOSFET and P MOSFET. N means it's an N channel MOSFET, P means P channel MOSFET. Then by the combination of these two, N channel and P channel MOSFET, a third kind of MOSFET has come up, that is called as a C MOSFET. What does a C indicates here? C indicates a complementary. C stands for the complementary, MOS stands for the metal oxide semiconductor. So CMOS is a device which is, or a transistor which is being designed or manufactured with the combination of PMOS and NMOS transistors. So these are the different kinds of MOSFETs. Structure of MOSFET. So this is a structure, how it looks like. It's a N channel. This is a upward look. When we take a picture of this MOSFET right from the top, it looks like this. You can see the source terminal which is connected to the ground. Because it's an N channel, the source of N channel is connected to the ground. If it would have been a P channel MOSFET, the source terminal would have been connected to the VDD, the main power supply. So now you can see this is one kind of notation. This is another for the N channel, and this is for the P channel. So here there's a gate terminal where the input signal has been triggered into the transistor as an input. There's a gate, source, gate and drain terminals, and this part is a SiO2 layer upon which the gate terminal has been laid upon, and this is the place where the diffusion, N type of diffusions are being laid in order to form the source terminal. And the top part upon this N channel N type source is the metallization part, and here it is a N type of impurities are being laid in order to form the drain terminal. Upon this one, this yellow one which you find here, it is a metallization through which this contacts cuts are being made in order to make the terminals. So now this is the region between the source terminal and drain terminal. It is called as a channel, and the length which runs from the source to the drain is called as a channel length. So it has been represented by L, and it's a conductive channel. It's a conductive channel. Why? Because the charge carriers, basically the electrons will be moving from the source to drain, so that's why it's called as a conductive channel. And this part is this entire thing is a substrate. And you can see here now, as I told, this part is a SiO2. You can see here the notation is given over here. It's an SiO2, that's a silicon dioxide. So this is regarding the structure of a MOSFET. Schematic structure of MOSFET. So this is how the schematic structure of MOSFET looks like. You can see here now metal gate and the gate dielectric, and this are drain electrodes. You have seen the drain electrodes over here. These are called as the electrodes. This what are the line you find, it is a terminals which are called as an electrodes. This is a drain electrode, and this is a source electrode. This is a channel length, and this is a silicon substrate. Working principle of MOSFET. Now let us see how a MOSFET works. The working principle of MOSFET depends upon a MOS capacitor. The MOS capacitor is a main part of this particular MOSFET. So now here the semiconductor surface at below the oxide layer and between the drain and source terminal can be inverted from P type to N type by applying a positive or negative gate voltages respectively. So whatever the layer you have found between the gate, which I have told is an SiO2 layer, that layer it can be inverted. That can be inverted by supplying a kind of voltage. If you are supplying positive or negative voltages, depending upon this positive and negative voltages, it's like this particular layer will be inverted from P type to N type. If you apply positive, it becomes as a P type. If you apply a negative gate voltage, it becomes as an N type layer. So that's how the inversion takes place depending upon the application of gate voltage. When we apply the positive gate voltage, the holes present beneath the gate layer, gate oxide layer, experience a repulsive force, and the holes are pushed downwards with the substrate. Definitely, why does this holes have been pushed downward? Because we know that holes will act as a positive type charges, and the positive gate voltage is applied. Whenever the same type of charges are positive voltage is applied and the positive charges come in contact, definitely a repulsion takes place beneath the gate surface, that's at the oxide layer, and because of that repulsion, there will be a huge amount of repulsive force whenever you increase the positive gate voltage. So because of that huge gate voltage, there will be huge repulsive force. That repulsive force will pull down this holes downward into the substrate. So that's what happens over here. Let us see the working principle. It's a continued. You can see over here how it looks like. We are supplying here the gate voltage supplied, and this is the gate and source voltage. This is a main supply. You can see SiO2 layer. It is a metal oxide insulator. You can find over you are supplying some positive voltage. Then the layer which is beneath this gate voltage will get inverted because of the repulsive force. That's what happens. Just now we have discussed. And here you can see what is ID. ID indicates it's a drain current. The drain current will be depending upon this voltage. It will be always from source to drain. And this is a P type of substrate. You can see the symbol of this MOSFET symbol. Still, we'll see some more interesting points regarding the working principle of a MOSFET. The depletion layer is populated by the bond negative charges which are associated with the acceptor atoms. Definitely, whenever this supplies holes have been dragged down, then definitely the negative layers, negative charges will be populated. The positive voltage also attracts the electron. That's what I told just now, up to now here. The repulsion takes place between the two similar kind of charges, that's the positive and holes, and attraction takes place between the unlike charges, that's the positive voltage and the electrons. Because of that one, that region depletion layer becomes populated. The positive voltage also attracts the electrons from the N plus source and drain regions into the channel. The electrons reach channel, and whenever the electrons reach, then the channel has been formed. It means, what does the channel is formed here? Here the channel formed means there is a connectivity has been developed between the source and drain. If there is a connectivity developed between the source and drain, through this path only the electrons can move from source to drain. Then only the ID has been formed, that's a drain current has been formed. So now a channel formed means, first of all, a path has to be created. So the electron reach channel that is formed. Now if a voltage is applied between the source and drain, the current flows freely between the source and drain, between the source and drain. So how the current flows? Whenever you apply the voltage, because of application of the voltage, the electrons which are formed over here, which are here in the channel, will get activated and they move from source to drain. This motion of electrons only we call it as a current flow. That current flow flows freely between source and drain, and the gate voltage will control the electron concentration in the channel. So depending upon whatever the gate voltage you are giving, if the positive gate voltage is less, then definitely what happens, some amount of electrons get attracted and they move excited and they move through the channel. If you are trying to give more amount of gate voltage, positive gate voltage, more amount of electrons are going to get attracted and they get activated and they try to move through this channel. So that's what happens over here. That's why we have written here the gate voltage will control this particular motion of the electrons in the channel. Instead of positive, if a negative voltage is applied, then what happens? The whole channel will be formed beneath the oxide layer. Why? Because again the same principle, when you apply a negative voltage, the electrons get repelled by the negative voltage and they move down into the substrate, and whatever the holes were earlier in the substrate, where they come into this channel, and in that way, because of the attraction, they come into the channel. Because of that thing of attraction, the whole channel has been formed over here beneath this oxide layer. So this is how a simple MOSFET will be working. So the symbols of a MOSFET, you can see here the NMOS enhancement type of MOSFET. Regarding the enhancement mode and depletion mode of transistors, I have given one lecture, and you can find that lecture of enhancement mode and depletion mode transistors in my channel. You can look into that working condition of what is meant by enhancement mode transistor and what is meant by depletion mode transistor. So now here this is how the enhancement mode NMOS channel looks like, and this is how the depletion mode NMOS channel looks like, or NMOS transistor looks like. And this is the bubble. If you find a bubble over here, it means it's a P type of transistor. It's a P type enhancement mode transistor. See, one thing I can tell it very clearly. If it is an enhancement mode, how to find out the enhancement mode? The difference between the symbols is that if there is a bulk kind of thing, if there is a like this thick kind of terminal here, that is called as a depletion mode transistor. Here we don't find in the enhancement mode transistor. That's a simple difference between the enhancement mode symbol and the depletion mode symbol. If there is a thick line over here, this is a depletion mode symbol. Now here you can see, anyway we know the difference between NMOS and PMOS is a bubble at the gate terminal. But here, in order to identify between the enhancement mode and depletion mode, you do not find any kind of a thick line at this part. It is called as an enhancement mode PMOS transistor. If there was a thick line, we call it as an PMOS depletion mode transistor. And this is another kind of notation for the transistor. It's an NMOS with a bulk contact. What does it mean? Here you can see it in the three transistors, there is no fourth terminal. There's a bulk. But here, this is how the fourth terminal, there's a fourth terminal MOSFET looks like. This is a bulk contact. Bulk contact is nothing else but it is, as I told, it is a body, or else it is also called as a substrate contact. So these are the different types of MOS transistor symbols. N channel and P channel MOSFET. So this is how the N channel and P channel MOSFET looks like. Here the arrow mark indicates into this one. If the gate terminal indication is if this particular arrow mark is into this one, we call it an N channel MOSFET. If it is outside, towards outside, we call it an P channel MOSFET. You can see this. These are the notation. VGS is a voltage between the gate and source. You can see over here R and R1 are the load resistors, and this is a main supply. 15 volts is a main supply, and the other terminal is a ground. These are two different types of transistors. This is an N channel MOSFET and this is a P channel MOSFET. N channel and P channel of MOSFET. If a MOSFET is an N channel or N MOSFET, then the source and drain are N plus regions, which I have told in the previous slides. N type of impurity has been diffused into that substrate in order to form it as an N channel MOSFET, and the body is of P type. Body means substrate is of P type. Then if it is a MOSFET is of P channel, then the source and drain will be of P regions and the body will be of N regions. So this is a difference, or this is really this slide tells about how a MOSFET has been fabricated. It is regarding the manufacturing part or a fabrication part of a MOSFET. MOSFET applications. MOSFETs are used in digital integrated circuits such as microprocessors, which are also used in calculators, which are right now we are using engineering calculators or different kinds of calculators, or the calculators which are right now present in our mobile phones. Or MOSFETs have been used in the memories, different kinds of memories we are using nowadays, like DDR4, DDR3, different kinds of memories, double data rate memories we are using nowadays, and those all the DDR memories in those MOSFETs have been used. It is used in the CMOS gates. Again, it is used in the analog switches. MOSFET devices are also used in audio frequency power amplifiers for public address systems. And also in all the mobile phones, whatever we are using nowadays, it is used with or being manufactured with the CMOS technology only. And also nowadays we are seeing that different kinds of air conditioned device machines or else refrigerators are coming up with the CMOS technology. So it means what, all those devices wherever the technology electronics has to be used there, they're using this MOSFETs. MOSFET application still is used in the amplifiers. It's used in the applications of power electronics and switch mode power supplies. MOSFETs are also used in oscillators in the radio system, used in the automobile. In different kinds of nowadays new technology, sophisticated automobiles are coming up. In almost every automobile we find the CMOS technology. And MOSFET switch. What does this MOSFET switch? This is a analog switch, which it means that here a MOSFET can also be used as a switch, like an on and off switch. So this analog switch uses a 4-terminal, simply generally enhanced. It will be in the enhancement mode, and MOSFET of either N type or P type is been used. In case of an N type switch, a body or back gate terminal or the bulk gate terminal is connected to the most negative supply, that is usually ground in the single power supply system, and gate is used as a switch control. So this is the design of a NMOS switch, how it looks like. And then whenever the gate voltage exceeds the source voltage, it means that whenever the VG exceeds or becomes much greater than the source voltage Vs by at least a threshold voltage, the MOSFET will conduct. Means what you are talking over here, every transistor will be having a minimum voltage in order to turn on. Means if you are trying to give some voltage, it will not be suddenly turning on at that particular voltage. Whenever the voltage comes to that particular point, that's a minimum voltage which turns on the transistor is called as a threshold voltage. The threshold voltage is a minimum voltage which turn on the transistor. Once this threshold voltage has been reached, then the transistor will be conducting. MOSFET switch continuation. The higher the gate voltage with respect to the source, lower will be resistance of the switch. And NMOS switch passes all the voltages less than VG minus VTN. So this is regarding, definitely whenever the gate voltage is more, the transition of the electrons takes place from source to drain. Because of that one, whenever the current is when the electrons are transiting, then the more amount of current is being produced. If current is more, definitely it means that resistance is less. That is nothing else but it's a Ohm's law. So now if a current is more, if a conducting of this transistor takes place means current will be more passing, that's electrons are passing from source to drain, then definitely the resistance goes down. So if a gate voltage is more, then definitely lower will be the resistance. When the switch is conducting, it typically operates in the linear mode, or which is also called as a triode region of a operation. Since the source and drain voltages are typically nearly equal, both will be in the nearly equal, and this is the two different types of say, what to say diagrams or symbols of the NMOS, where you can see in the first case here, this is a symbol for which is given, which tells that NMOS is where the VGS, the voltage between the source and drain, is greater than the VT. Whenever it's greater than VT, then what happens, this NMOS will be turning on. Here this is a voltage, this is a PMOS type of transistor where VGS is lesser than VT. So definitely what happens, the voltage which you apply at the source and gate terminal, it has to be much greater than the threshold voltage, then only the transistor conduction takes place. The characteristics of the turn-on situation of a NMOS and PMOS transistors. You can see now what are the blue line, you can see now up to here, it is a minimum voltage which requires by a transistor to turn on. So that is what we call as a threshold voltage. So it's a this part you can see now, this is a threshold voltage of a NMOS transistor, and this is a threshold voltage of a PMOS transistor. So you can see now this is the threshold, this dark line, red line is a threshold voltage of an NMOS transistor, and this blue line is a threshold voltage of an PMOS transistor, and this is the conduction phase of an N channel MOSFET, and the conduction phase of an P channel MOSFET. So there's a characteristics which has been drawn against current IDS and also VG. It's a IV characteristics of a, or VI characteristics of a transistor, which tells about the turn on situation of a transistor. Advancements of the MOSFET. The explosion of digital technologies has pushed the advancement of MOSFET technologies faster than any other silicon transistor. MOSFET, because MOSFET is nowadays been used, and it has got much more benefits and advantages than the other MOSFET. Why? Because it's a low power device which consumes very less power, and it delivers a great amount of performance than compared to the other transistors. So that's why it is MOSFET is being used in nowadays technologies. This happened due to the MOSFET being the prime building block of a CMOS digital logic circuits. The CMOS circuits are advantageous because they allow the virtually no current to pass through and thus consume very little power. So this is a main advantage part of a MOSFET. Limitations. The limitations of MOSFET is overheating is very much a concern when considering today's integrated circuit. Why? Because whenever the large number of transistors nowadays, nearly some billions of transistors are being used in order to make up a integrated circuits. If all the transistors are working, then definitely what happens, because of the rigorous working nature of a transistor, a large amount of heat is being produced, and because of that one, overheating takes place. This overheating has become a much more concern considering that today's integrated circuits contain millions of transistors in a relatively small space. Recently, a small size of MOSFET has created operational problems, such as producing such tiny transistors is an enormous challenge. So definitely producing a small transistor, nowadays the technology is of nearly 2 nanometer technology, and you can imagine how small is a 2 nanometer. The size of a human hair, the thickness of a human hair is 90 nanometer. It's of nearly 900 nanometer. You can imagine what is the size of a today's transistor size. The human hair thickness is 900 nanometer, and the size of a transistor is only 2 nanometer. You can imagine how small is a transistor. So that's a building up of that kind of transistor is a challenge. It's a great challenge. And thank you everyone. I hope you have understood what is meant by MOSFET and how the MOSFET has been manufactured and different kinds of MOSFET. If you like my video and lectures, kindly like, share and subscribe my channel so that I can come up with much more interesting topics regarding the electronics. Please circulate this channel and also videos with your friends and the people who are very much interested in knowing about the electronics. Thank you everyone.